Everyone, welcome back to SAT Math Question of the Day. Here's our question. Please read it, try it, pause the video, try it, come back, and we'll do it here. Line P is defined by 4x plus 8x equals 6. Line R is perpendicular to line P in the xy plane. What is the slope of line R? This question, according to the College Board, is marked as a difficult question. But I would argue with that in that it's very straightforward what you need to do. You have to get the slope of a line perpendicular to another line. That's it. There's nothing more to it. And that's just it's almost like conceptually it's just one step. Just get the slope. But anyway, you also have to know that the slope, line R's slope, or we say slope. Oh, Seth, I know you like the thinner font. The slope of R has to be -1 over the slope of P. So once we get the slope of P, we take the negative reciprocal, we get the slope of R, and we get the answer. So then it's just a question of getting the slope of this line, which you could do either way. In a bunch of ways, you can memorize the formula for the slope of a line written in AX plus BY is the C form. I certainly don't suggest memorizing any formulas at all. So you just solve for the slope, which seems like the cleanest way to do it. A good way to do it is get it into the form y is equal to mx plus b. We don't really care less about the b. We really only care about the slope. So you want to get the x to the other side and divide by 4, and that would be the slope. So let's do it. So it would be 4y is equal to -8x. You divide by 4, and you get -2. And that's it. So it means the slope would be the slope of this. Right. So the slope of R would be 1/2. Because if the slope is -2, right? The slope is -2. Then you take the negative from -2, and you get +1/2. That seems to be it. I mean, it's very. As long as you know how to get the slope of a line perpendicular to another line, then it's an extremely straightforward problem. And also you have to know how to get the slope of a line given the equation written. Just given an equation. Given an equation of a line. And that's it, right?
Right.
Yeah, I think so. That's it. Any other comments, Seth?
No.
Oh, wow. So I'm not sure why the SAT people mark this as difficult. This comes from on the educator side of the SAT. They offer a load of questions marked by type and difficulty. And shockingly, this was marked as difficult.
So maybe because it's a two-step problem.
Maybe. I mean, I just want to show. Let's see if I could do it. You see right here. This is the question. It's algebra, linear equations in 2 variables, difficulty 3. So let's see what their answer is. Well, their answer, because it's free form, they allow the answer in either form, 0.5 or 1/2. And I think that's what we got. Yeah, we got that. Positive a half. So let's see how they do it. Okay, so the correct answer is a half. An equation in that form represent, okay, so we subtract 8. This is exactly what we did, dividing both sides by 4 gets that. Notice that you really don't have to waste your time with this. This is a who cares. Don't waste your time with 3/2. Thus, the slope of the line is -2. If it's perpendicular, it's a negative reciprocal. That's just what we did, negative reciprocal. You don't really even have to write this out. Just know the negative reciprocal of -2 is +1/2. You don't really have to write it out. You can just do that in your head. Wow. So so you think that they marked it hard because of You have to know one thing about negative reciprocal slopes, and you also have to know how to get the slope of a line, but also you have to know how to put together a two-part problem. So,
Mm.
yeah,
Yeah.
yeah. So, go through our questions. The first question, which is obvious, does the answer help you? Well, of course not, because they don't give you an answer. It's all the you have to answer. You have to answer it yourself. Calculator, no. I mean, probably not. The calculator doesn't really help you. How does this question differ from a question you'd have on the school test? It'd be the same question. Is there a particular pattern to this question that makes it go faster? Is there a particular set of numbers that they chose that allows you to see the answer faster? No, no. Just a bunch of even numbers. I mean, you could simplify this. You could factor out a 2 and make this 2y plus 4x is equal to 3 if you want and deal with this, but no, really. And I guess the main idea of the problem, which is the most important question of the questions we ask, is what was the College Board trying to see if you knew how to do? And one thing is how to deal with a multi-step problem. And number two, knowing that you absolutely have to know that the slope of two lines are perpendicular, the slopes are negative reciprocals of each other. That is an absolute must know. That's for sure they're asking there. They want to see if you know that. And also they want to see if you know how to get the slope given a relationship, given an equation with x and y. Yep, that's what they were asking. Um, yeah, and one thing to remember about negative reciprocal slopes, which could come up and could be very useful. To make it hard darker print, change the color. If you have two slopes, R1 and R2, they multiply to negative 1. R1 times R2 is equal to negative 1. You don't normally see it written that way. R1 times R2 is negative 1. But sometimes thinking of it this way can be very, very helpful. For example, if they give you the two slopes and you have to solve for some sort of coefficient, then you would write the equation R1 times R2 is equal to negative 1 and solve for whatever unknown comes up in this type of relationship. Oh, that's really
Okay.
useful.
Why is the slope of a line perpendicular to another line with a slope r equal to the negative reciprocal of r?
That's a great question. I don't know if I could. I think once you explained that to me, it was a really brilliant answer. I bet there are different answers to that. So, yeah, go ahead. Let's hear.
Mm,
This is a great question to
well,
ask because this way everyone will understand it better, including me.
well, I don't know. The explanation that comes to mind for me is,
We could give you some white space. How about if we give some white space?
you know,
How about that? That's
yeah.
nice. It's a
All right.
nice amount of white space.
Okay. What am I doing? Okay. Yeah. So here we are. Where can I write it?
Uh, I lost my annotation. So I just I lost. Okay, fine. Here. Between here and between here and here. Okay, got it.
Okay.
Yeah, go ahead.
Yeah. Okay. So let's draw a couple of axes. And let's draw a line. Let's draw a line to the origin. Right?
Okay.
There's that line. And then let's see what the slope is. Let's indicate how you define the slope. Well, what you do is you consider, oops, consider this figure and extend it to a rectangle, right?
Yep.
and let's label two of the sides of the rectangle. Let's label two of the sides of the rectangle. Uh, and I want to get I'm messing with
Just draw it. Don't be fancy.
hold on. Hold on. I'm messing with
You're gonna put people to sleep. Stop messing.
uh,
Just draw laying.
okay, got it. Okay, so now what am I doing? Black. So I'm going to write a couple of symbols for the lengths of the sides of the rectangle.
Okay.
Okay. And then we get the slope of the red line equals delta y divided by delta x.
Okay.
Y. Now what we do is rotate the figure by 90 degrees.
Okay.
So what I'm going to do is, so if we rotate it by 90 degrees, we get a revised figure like this.
Yeah, I mean, in the interest of time, you can just draw it in. You don't have to do the fancy straight lines. Oh, that went over the
Well, I
thing.
do. Okay. Well, it's not quite accurate. And then I will
Well, it went
draw
over.
this red thing. Uh, oops. Uh,
You're above
sorry.
the line. Okay.
Okay, here we go. So draw this. Okay.
Fine.
Now, so we rotated the red line by 90 degrees to get a thin red line.
Right.
And let's write in
Yeah,
the
let me do it.
values.
Let me do it. Let me
So
do
the
it. Let me do
top
it.
the
Let me do it.
top the top this you know the
I
thank you.
wrote it in. I wrote it in. There.
Okay.
Okay. There we go.
Yeah, delta x of those. So the slope of the slope of the perpendicular line equals, you take the difference. No. Okay. Now here's the deal. So you take the different. So let's see. Let's figure this out. This is delta x going up, but uh, delta y here is positive, but here this is actually negative.
Right, because you're going in this direction.
Yeah, yeah.
Yeah.
And so the slope of this line is delta x divided by negative delta y.
Right.
And these two are uh, they are negative reciprocals. You know, you get one from the other by reciprocating and taking the minus.
Yeah. 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 Yeah.
Yeah,
I mean, you could also you could almost see it, right? That one of them is a positive slope and one is a negative slope.
yeah,
Yeah.
yeah,
Okay. Great. Cool. That's a great way to see it, and
yeah,
that's a great way to
yeah,
show it.
yeah,
Okay, so I guess we're done for today, right?
yeah.
Yeah, okay. I'm Joel. I have a PhD in mechanical engineering. My brother Seth has a PhD. We really are fraternal brothers, right? Yeah, fraternal brothers. And my brother Seth has a PhD in math. We are here. We try to meet every day. We go over one SAT model question and we try to piece it out, go over how to do it, go over the concepts behind it, so that you would be prepared for other questions that use the same ideas. And that's practice. Do as many practice tests as you can from Blue Book, and whatever unit, whatever topics you weak on, go to Khan Academy, where College Board is partnered with Khan Academy to give you a load of problems on each topic. Practice on those, and just keep practicing, 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 and learn from your mistakes. Okay, everyone, and try to understand exactly what's going on in each problem. And what we also try to do here, we really didn't need it, but to look at the problem from different ways and different ways of doing it and through different lenses. But in this problem, it wasn't really necessary. Okay, so I guess that's it, right, sir?
Hey,
Yeah,
yep.
we're done for today. Okay, everyone, have a great day. Take care. Bye.